All right, welcome to the channel. And obviously you've clicked on my video because you're interested in mini splits. Now, this is not something I normally put on my channel. I normally put stuff usually related to working on a Mustang or other things, but I am not one of those that is stuck on one thing. I just make a video about what I want to make a video about at the time. That's why it might be about the lawnmower, it might be something else. I just make a video, put it on there. But I have a lot of information that I want to convey about mini splits. And there's a lot of videos out there that these guys will just show you, oh, we bought it, we put it in, we did this. But there's a whole lot of minutia in deciding which mini split to buy. Not just which one to buy, but what features you may want and other things. There's a lot of considerations to go through before you decide which one you want. So that's kind of where I'm going to go with this. And I have my paper thing set up here with my list of stuff here. I don't have a fancy teleprompter. I'm not that high tech. I'm not that good. I just make my videos and I just make them. So, you know, bear with me and we'll get through this till number 20. I got 20 things to talk about here. So let's get started with that. All right. So the first thing I want to discuss is the fact that when I'm talking about mini splits, I'm talking about the primary use of it being in a workshop. Now, is a workshop, garage, things like that, not in your house. So there's going to be a lot of things that I'm going to gear towards that may not, or I know will not, apply towards a house. So just kind of keep that in mind that I'm talking about a different application. So there's a lot of things that a lot of people are going to say, well, this is what we do in house. Well, doesn't work that way in a shop or garage or things like that. There are different considerations. First of all is, you know, why would I put a mini split in a workshop? Well, you've got window units, you've got, you know what a window unit is. Everybody knows what that is. You know, they're noisy. You got to cut a hole in the wall. They're not the most efficient thing in the world. I actually have a 2-ton one at that end of the building right there. This mini split back here is to supplement that. And hopefully in the future, I do want to get another 2 tons of mini split in here because this is not enough to heat. It's not enough to cool, but it's enough to help maintain and things like that. I can use propane to get get it up to temperature really quick when it's really cold, or I can kick on the 2-ton over there and bring that air conditioning down and cool it off much quicker. But that's not a good. That uses so much more electricity. It's something like when I do the numbers, twice as much electricity. When you figure cut it in half to 1 ton and the amount it uses to cool, it uses twice as much power as this mini split does. And it is not a super efficient mini split either. So, you know, window unit, not a great solution for the workshop, unless you just happen to have a small garage, you got a window, throw it in there, boom, done, good. I don't blame you one bit. There are some great ones out there that are far quieter, inverter compressors and things like that. Now, another method you can go is with a P-tack. And hopefully I put a picture up here, but a P-tack is often called, I call them hotel units. It's a hotel unit. It's what you have in a hotel. It's just a massive window unit that goes through a massive hole in the wall. Again, same issues as a window unit. And they are usually quite a bit louder. There are heat pump versions. There were some propane versions at one time. I don't know if those exist anymore, but those things can be had sometimes relatively cheap, and you can get surplus ones, extra ones, damaged ones. Not a horrible solution, but it's as far as I'm concerned, it's not the best, because also you've got to cut a big hole that's like 6 feet wide, you know, sometimes 6 feet wide by, you know, this tall, and you've got to cut through and you go to the outside. Not always the best solution for a workshop. And the one I come to is a standard split system like you would have for a house. That's where you'd have the, you're going to use it, say this is our condensing unit, it's going to be outside, and our evaporator will be somewhere in here, and we'll have to set up some sort of ducted system. So you'd hang it from the ceiling usually and put filters on the intake side and run a duct out and just let it blow down to that end of the building. And that's a lot of times how you do it in workshop. That is actually probably one of the most economical ways to go. Those are available, you know, in air conditioning, heat pump. You put a gas furnace, just no different than a house. Those are probably the most efficient way. For the cost of the amount of tonnage that you need and efficiency, they are still hard to beat in a lot of ways. And you also get filtration, which we'll talk about later. And then the other one I come to for a workshop is this is a great solution for a lot of things, except that this solution is not efficient, and that is a package unit. Insert picture here, hopefully. But a package unit is basically, you take a window unit, you add some ducting around to it, you put it outside, and you have a hose that goes in and a hose that goes out of the house. So for a workshop, they're actually a great idea because I can put that unit outside. I can run one duct in, and I can put some big filtration on it. I can run the other duct through a hole, go up, run down, put some, vents blowing off into the building as you go down there. It's a great solution for that. It's all self-contained. It's all one big unit. It just works when you get it. You just plop it down, you hook power up to it, you hook the vents up to it, and you're up and running. You can get great filtration with that. Again, subject down the line, but they are very inefficient. And those are also available in propane, natural gas, with the electric air conditioning side, and heat pump. So that is a doable thing as well. And if you have a small workshop and you have access to one of those and electricity is not a big deal, it's not a bad solution. So next part I've got here is on my number 2 is going to be sizing. Now, most of you are going to say, oh, let's do a manual J and we'll figure out the sizing and all this. Doesn't work on a workshop. Doesn't work. There are commercial guides to do that, but I don't know of any that are on the internet that you can go on to and use that get you close to what you have, say, for doing a house with a manual J on the internet. I have not found one of those yet. That said, when it comes to your sizing, it's going to kind of be one of those things where you're going to have to kind of figure this out on your own. You might want to get some references from local places that's similar size buildings, similar size shops, see what they've got as in way of their, what they size there to, how they use them, because part of your sizing is you got to figure out what's your heat load. Are you doing stuff in your shop that creates a lot of heat? Because I'm primarily cooling here. So you're doing stuff that creates quite a bit of heat. You are going to have to do something to mitigate that heat. And that's going to mean more air conditioning. So you have to kind of figure out what's that, how much is it producing and how much more air conditioning you need for that. The building construction. This is a metal building. This is a red iron metal building. So all the corner posts and every 10 feet on the walls it's about a 3-inch pipe, pipe about that big, and it is welded to a plate that is concreted in. And those run vertical all the way around. And then on that, you've got a 2x2 frame that runs at the bottom, down to the floor, about midway or so, depending on the height. There is a point where you have to add more, but this is the height of this building. You have a 2x2 midway and another one at the top. And that 2x2 will be welded to this frame. And then you'll have some sort of trusses up here, which I do have some trusses up here that you can't see right now, but you'll have some 2x2 welded trusses as well. And you'll have 2x2s running down this, and then you'll have, in my case, this was originally insulated. Now, metal buildings are insulated with, basically it's a fiberglass that they just kind of drape over top of it. They throw the metal on top. Very poorly insulated because the sheet metal is attached to those 2x2 posts. Well, your insulation went on top of that too. So that means when the sun hits that metal, it heats the sheet metal and is in direct contact with your 2x2 pipes. So in the summertime, I've got these, my shop is 20 by 40. So you've got 40-foot radiators all the way down the building. And these things are putting out, 120, 130 degree temperatures, heat off of it. They're 120, 130 degrees in the summertime. So those things are radiating heat on this side, my side of the insulation layer, because there is no thermal break between that framing and the skin on the outside. There are ways to do that, but it is not done. So that's one of the issues you have with the metal building. And as you can see, I am actually framing the inside of this building with 2x4s, adding more insulation and then plywood on top. It's a slow process, but it also gives me, because of metal building, I don't have walls. I want to nail something to the wall. I can't. I want to hang something to the wall. I can't. I have to add more structure in order to do that. So when I get this framing done, I will have a way to do that, and I'll have a much better insulated building. Now, if you have a wood building to start with, wood-sided, your heat load is going to be lower. It's going to be a lot lower. So things like that you want to kind of keep in mind. All right, so next item on my list here, we're on to number 3 now. How many units do you need? And that goes in with your sizing. And what I'm going to bring into here is I bought a 1-ton unit out here. It's not big enough. I know it's not big enough. However, when you start looking at doing the math and you figure these things out, generally these things are, $500–600 a ton. Whether you buy one unit that makes 12,000 BTUs, or I'm sorry, one that makes 24,000 BTUs, or two that make 12,000 BTUs. So for the most part, you're in the same boat dollar-wise per ton. For the most part, there are some variations on some of these where you may get a little bit of a price break when you go to a 24 versus a 12, and I'm just using those as a guide. So you may get a variation there, but you're not paying any really an appreciable amount less to go up to that 24 versus 2 single 12s. And where you can benefit from this is, say if it's the same price for 2 of those little ones, why would I buy one big one? I would buy 2 small ones, put them in different locations, which gets you a little better, airflow through there, and also gives you redundancy. So if something happens, you're out one, the other one's still working. Something to keep in mind. Okay, now how do you want to mount this thing? Do you want to mount it on the wall like that? Which you can. This is a standard wall mount that I have in here. My standard wall mount. Everybody's very, very familiar with those. There are also units that mount against the wall on the floor. So say you could under a window or things like that. There are units that do that. There are also units that if you've got a ceiling that you can frame into, that you can put it up into the ceiling and they are flush with the ceiling. Those are finally starting to get more popular. The ones that are on the wall of the floor, those are never been popular anywhere that I know of. They're just kind of the odd duck of the mini split market. Then there is also the ducted mini split, which is basically a small air handler that you can mount into an area, run a duct system. That's generally outside the scope of what you're going to want for a workshop, but they do exist. They do have some benefits. Again, you can do more filtration with them. So the issues you do have with when you go away from that wall mount right there and you go to a ceiling mount or a floor mount, a ceiling mount, floor mount, or any of these other oddities, you now have to deal with the condensate, which means the water that comes off. So when it's in cooling mode and it is, wringing that moisture out of the air, that water's got to go somewhere. Well, you're going to have a condensate pump. Some of these units, like the ceiling units, will have one built into it. So that is a pump that actually will pump the water through a tube to wherever you run it outside. It's another maintenance issue. They do kind of slime up over time because they're generally in a hot area. So it's something to keep in mind there. And then if you've got one of these wall mount ones that are down low, same thing there. You will have a pump in that. The other time you will need one is when you have one of these wall mount units and you're not putting it on an outside wall. As soon as you put that wall unit on an inside wall somewhere, now you've got some issues to deal with because your line set is going to be more difficult to run for one, but also you're going to have to run a condensate pump because you're going to have to pump that water out of the unit, up, over, and down to wherever it needs to go. So that's something else to keep in mind when it comes to which ones you want to pick and how you want to mount it. Okay, now we've talked about single systems, single head systems, all sorts of different varieties of that. Now, the other one is going to be multi-headed systems. Now, multi-headed systems do have a place. In your workshop, I don't see them having a place in a workshop. That said, if you're in a house, they do have a much better use in a house. And let me break this down really quickly because I just brought up the first one I could find, and this is kind of illustrate where we're going from. This is a 3-headed system that I found. It is a 27,000 BTU condenser, 18,000 BTU inside unit, and 2 more 9,000 BTU inside evaporator units, depending which way they're running. Well, I don't know about you, but when I add 9, 9, and 18, I get 36. Well, 36 is more than 27. So in a household, that works just fine, because in a house, you are going to have varying loads in different rooms. So you're rarely ever going to have all those units need to be running at full throttle. That's rarely ever going to happen. So it really doesn't, it's fine in a house. So, but in a workshop, when you're out in your workshop, generally, these units are going to be running full throttle. If you're out here working, whether it's you're heating it or you're cooling, you're going to run them at full blast all the time. That's all they're going to do, because most of you are not going to have your shop air conditioned all the time. You're not going to have it heated all the time, or you may have it set to a temperature and try to bring it up. And basically, you're going to need all the oomph that you can get out of these units. So that's where you do have an issue with a multi-head unit. The other issue you do have with multi-head units is also with this particular one, and I talked about line sets earlier, but the length of line sets. Some of these come with 9-footers, and 9 to 16 is a really common length. I've seen a few 8s. But you've got a condenser unit like this with 3 sets of fittings on it that has 3 heads and has 3 line sets that come with it. These line sets are 16 feet long. So let's kind of think about that. So you've got this unit here, and the stuff that it comes with allows you to run 3 heads only 16 feet away from this thing. So run 1 16 feet that way, run 1 16 feet that way, and then one right over top of it, or 1 16 feet straight up, or that direction over there. The line sets that come with these 3-headed, 2-headed, 3-headed, 4-headed systems, whatever it is, they not really usable length line sets as far as I'm concerned, because say if I wanted to do multi-headed system in my shop, or say you've got a house and you want to do a multi-headed system, say I'm going to put my condenser on the other side of this wall over here where I have mine right now. Okay, that's fine. Well, this unit right here, that needs to be about say 10 feet. Just say that took 10 feet of line set. Well, your one line set is fine. Well, I need to have another unit down at that end of the building, and by the time you add up, down, over, around, and all these things, you're in the 50-foot range that you need a 50-foot line set to get over there. And then if you've got a third one, how far is that going to be from where your condenser is? And in some cases that may be your choice. That may be your only choice, is to do a multi-headed system, because I've only got a 220 room for one 220 outlet or 220 breaker. I got room for one breaker for one unit, so I can put my one unit in, and I just know that realize that I'm going to have the issues with I'm going to have to run really long line sets, which is it's a hassle and it's a cost, and so on and so forth. I generally see it as running electricity to where a condenser is generally cheaper and easier than running copper line set. So just something to kind of keep in mind there. But they are a good option for houses, and they can be a good option there. And if you are constricted in your units the way they need to be, a multi-headed system might be for you. For me, it really isn't. It doesn't make sense because the distance is involved. And this unit I'm looking at, and the brand really doesn't matter, but this is just the first one I came up with, and this is a 3-headed system with a 27,000 BTU outside unit. Is $2,400, right now $200 off, so $2,200. That's not a horrible price for the tonnage and the fact that you're getting 3 head units, but keep in mind that when I talked about line set length, when you start adding up what it's going to cost you in line sets, you've got to buy some pretty long line sets, and some of these line sets can be $100, $150, $200. Sorry about that. But they can be quite expensive line sets by the time you start adding in how long of a line set you need. And then on top of that, you're going to most likely have to add refrigerant to that system at the same time as well. So that's why I tend to elect it to the way of single unit systems everywhere you can go, as long as you have somewhere on the outside to place that unit and make that line set as short as possible, if that works in your favor. But Don't get me wrong. I'm not trying to say, hey, multi-headed line sets are really bad. They're a bad thing. Don't do them. They fit a very niche usage. They do come at a higher cost in the end, but they do have a place for the workshop. Not always. Now, say I wanted to put 3 heads units in here, and if I wanted to do that, and I put the condenser say in the middle of at the back of the building in the middle over here. I put a 1 head unit in the middle. I run 1 head unit over here, one at that end of the building there. That is not a bad solution, to be honest. I don't. I do from in my situation. I would not put a condenser on that side of the building because it is in a essentially kind of an alleyway. So I don't want a condenser out there. So that's why I would not do that there. So just things to keep in mind on the triple-headed systems, double-headed systems. But when you see that 9,000, 9,000, 18,000 on those inside units, that doesn't mean that that's what you're going to get total. What you're going to get is whatever the rating of this thing is, which is not going to be that full rating of those inside units. So if this one's running at full, this one's running at full, the other one's got to be running at a lower capacity. So just something to keep in mind when it comes to multi-headed systems. All right, refrigerant type. Now, there are basically 2 refrigerants. There's 410A and there is R32, basically. Now, 410A is the old stuff. It is being phased out. It is no longer being manufactured, but units still exist with it. 32 is what is now becoming the norm. It is what we have everything to use now. It is a hydrocarbon refrigerant. So that's something to keep in mind, but don't worry about it. To be honest, been using it in Germany for decades. It's been used. They use them in refrigerators and stuff. This is nothing new. It's just new to us in the U.S. We're kind of a day late, dollar short when it comes to a lot of this stuff, unfortunately. So when it comes to that refrigerant, it's like, do I want to pick a 410 over 32? The only time that I would worry about it is if you are going to buy a system put in a system where you need to put a really long line set. Whatever you can get refrigerant for, go with that one. Because right now R32 is not the easiest thing to get a hold of at this moment because it's kind of it's the new thing in the world for us here in the US. There are alternatives that some people will do. I do not recommend them, but it can be done. Just so you know. All right, compressor type. The actual type of compressor that's in this. Now, the old days of air conditioning, you would have a piston type compressor. That was it. And then we got into the scrolls, which is 2 little scrolls that kind of do this together. And that's just kind of the newer thing that we have now for regular, American style, ka-chunk type of compressors, because, it's still kind of caveman style on our compressors in the US here. So they're, it's like ka-chunk, they're on, ka-chunk, they're off. They're not very smooth. They're not the most elegant things in the world, but they do work, and they are cheap to make compared to the other alternatives in the world. Now, you can get different kinds of these compressors, and the main thing is that you really need to just, when you're looking at them, make sure it's inverter type compressor. There are some older units out there that'll still be out there, or some really low end units that will have like a very simple rotary type compressor that is a 1-speed compressor. That does exist. So they're getting rarer, but that does exist. I would stay away from them. I would go for, make sure it says inverter on there. And it may be kind of hard to find sometimes, but it will generally be right on the top. Inverter is what you really want to go for. All right. Now, we're going to talk about line sets, because it is an important thing when it comes to these. Now, when you're picking your units, you need to know how long your line set needs to be. And you need to be careful, because some of these units, sometimes they'll be priced out there. It's like, oh, it's only $400 for this unit. Doesn't include the lines. It doesn't include the line set. And the line set, they can get quite pricey. In fact, there's some units that I've seen out there, various brands. I'll look at a unit, say it's not a bad price for the unit. Oh, you need a longer line set? Oh yeah, that's as much as the whole unit is in some cases. So you really got to watch your prices on line sets. How long do you need? Some are 9 feet. some are 12 feet, some are 15 feet is about the most that I've seen come with one of these kits without basically specifying a different size length. Some of these you can run up to say 50 feet long, and they will let you do that. However, when you do run a longer line set, when you will look in the specs, it'll say there's enough refrigerant in this unit to run a line set, say 15 feet. Anything past 15 feet, you're going to have to add refrigerant to that unit. And that's what I was talking about earlier on the line set. So that is something to keep in mind. All right. So what I have here is this is actually the leftover from one of these type of units that I installed several years ago. 5, 6, 7, probably, geez, it's been several years ago. This is a brand new unit, just so you know. This is 18,000 BTU that I have not been able to find an inside unit for. It was made by Amcor Air / Pritium, and I looked for an inside unit for a long time because I wanted to use it. I could not find one, so it's just been moved around and then put outside. So that's what I have these from. Now, this is a better quality insulation that you will find on some of these line sets. And a line set is it's just copper. It's just copper tubing. It's copper tubing. Usually, a lot of them run about 3/8 for the liquid line, 1/2 inch for the vapor line. As you get the bigger units, you will need larger lines. So the insulation is a thing that needs to be looked at, because this is actually a pretty good insulation here. This is pretty nice stuff. And this has just kind of been moved around the shop, and it has held up really well. It came with a really good quality insulation. That said, there are many units out there. This is packaging foam. This is that foam that you get in all kinds of boxes and, padding around your sheet metal parts and things like that. This is often used in a tube form for insulation for these line sets. So while it works, it's not the best thing in the world. So when you start looking at really low-end line sets, keep in mind that insulation that is on it is probably where they're cutting their cost in order to keep the price down on that line set. All right, so we'll move on to number 7 on my list, which is efficiency. Now, if you're going to run your unit a lot, go with a much higher efficient unit. If you're not going to run it a huge amount of time, you can probably save some money and go with a lower efficiency. And you're going to find some that are usually at the low end is going to be 17. Now, we went from SEER to SEER 2 on the rating styles. For you guys out there, just kind of ignore it. It is what it is. Let the guys that do HVAC, let them worry about it. But it's a comparison. So you can use it for comparison, and most of them are now going to be rated in SEER 2, which is supposed to be closer to real world uses. I don't know how accurate that really is. I haven't done enough research on it. So you can get 17 SEER all the way up to 30 plus SEER. There are some of the high-end Mitsubishis and things like that are in the 30s. That is incredibly efficient. Is it worth the cost? That's up to you. My rule of thumb is I do not want to do anything that is less than a 19. Ideally would be a 21 SEER or better. That's for me. I would ideally have 21 or better. The lowest I would do would be 19. And in the down the doogly-doo, I'll put a comparison in there for a SEER rating that you can put the SEER of one unit versus another unit, and it will give you an idea of operational cost. Now that's over a year, because it's a seasonal efficiency rating. So it's going to be over a year. So that's not going to be 100% accurate for what we're doing in a workshop, but it'll give you a ballpark idea of the difference between, say, a 17 and a 19, or a 17 and a 21, or a 17 and a 25, and things like that. And you can put your how much your electricity cost is in there and everything. It's just a nice little calculator by one of the HVAC company producers. All right, so okay, now we get to heating temps. When it comes into that efficiency, that can be a big deal up north. So some of these units, they will only heat down to, I'll just pick a number. It'll heat down to 15 degrees outside, Fahrenheit. So it'll heat down to that temperature. And then there are ones that will go very low. Some of them, I got one I was looking at, it will heat down to -13. The thing to keep in mind when you do have these ones that will heat down to much lower temperatures, the efficiency drops off a lot the colder it gets. And your efficiency, capacity, and all that drop off. Now, one of the issues you will have is that when you're in that start getting below freezing outside, that the defrost software is going to start kicking in. The colder it gets, the more that thing is going to go into defrost. And that is one of the things that does annoy me about this one here, is that when it gets below freezing or so outside, it tends to go into defrost more often than I would like it to. And unfortunately, I have not found a way in the software, in the app or anything else, that where I can adjust the defrost times and things like that, because, excuse me, sorry about that. But I have not found a way to adjust the defrost times on this, and I would like to, because I would like to lengthen them out, because there's only a few times, like when we had the 5 inches of snow the other week, that we really have a need for defrost, and where it was just, the humidity was 90 something percent, and it was just right around freezing or so. And no, oh yeah, it needed to defrost, but it didn't need to defrost as much as it did. Because even when I would go out there and look at it, yeah, there's just water pouring off of it, but it never got massive amounts of ice on it to the point where it was like it really needed to defrost. So it's a little more active on the defrost cycle, which I believe on this one is probably every 30 minutes or so when it is really cold outside, because it does have temperature sensors that it uses to gauge all that by. So that's something to keep in mind, that if you can control your defrost cycles, that would be a good handy thing to have. That does exist. Mine does not have that. All right, so voltage. Should we get a 110? Should we get a 220? Us 120, 240, whatever. Don't care. Let's not get into that discussion. The only thing I will say there is that I would say go 110. If you can go 110, go 110. This one's 220 because the 221 was cheaper, and I have the extra slots for it in the breaker panel. That's the only real thing that comes in, is that generally on these units, most of them are going to require the same size wiring. In say 12 gauge wire will power a lot of different size mini splits. So when you look at your ratings on there, you'll have to look at it, find out what it actually requires. But a lot of them say a 1 ton and 2 ton. It's going to require the same wiring either way. So the only thing that you're changing there is that you're using one more breaker slot to go with a 220. That's the only thing you're really changing there. If you were to go back with a 110 and you have, say, you've got solar panels, I would love to cover the roof of the shop in solar panels. I have a huge area up here and it's in the sun all the time. It would just put out power all day long. But if I did that and I had one of those, box on the wall for it, I would want a 110 volt version, because the inverters and the solar equipment we have for us here in the US, because we have 110 and 240, 220 stuff, it would just be easier with a 110 unit. Okay, filtration. You're not going to filter the air. So, if you're creating a lot of dust in here, you need to keep that in mind. That thing has the same little screen thing that a window unit has in it. It just keeps the big bugs out. It does not filter the air very well at all. So that's just the way it is with these things, and it's something you got to live with. Or you can go to, and I'll put the links down in here for a couple of videos. Sorry about that. I didn't write this down, and I had a brain fart. The couple of videos are on Jay's Custom Creations. He does woodworking. He's doing this. He's got a second channel where he does. He's working on his little piece of land out in Mississippi, just having a ball building his new place. But in his old shop, he did a couple of excellent videos on a filtration system, and others have done it. I just like his. I like the way he did his video, so I'm going to link to that. And basically building a large box with large filters. You don't just want one, you want multiple filters, kind of like he did, because you don't want the resistance to airflow. Because that's a big deal killer with these things, because they can't just pump through air like a conventional unit would. So I'll put in, I've got 2 video links I will put in. One is for his install, and one is for his, I believe it's like a 1-year update or something, where he goes in and checks the filters. And he's in a woodworking shop, so you take that into consideration as well. And definitely check out his channel if you're interested in woodworking or shop building and stuff like that on his other. It's yeah, great guy, really cool guy. All right, now we're going to get into the Wi-Fi controls. Now, you know, everything is an app these days. You do have your remote control, that's fine. Some units will, most units will actually have it if you go with the higher end units. The higher end units will have it. Some of the really cheap low end ones, it will be a separate module that you have to buy separately, plug into the unit in order to get the Wi-Fi control. If you have a unit for some reason that does not have Wi-Fi control at all, there are units and controls that can be adapted to those mini splits to make them Wi-Fi controllable. Some of them are just infrared transmitters. Some of them are actually hardwired into the unit itself. So that is a thing. It does exist, but it adds in the cost. And sometimes if your unit does not come with the Wi-Fi, sometimes these modules can be $30, $40, $50 for the module. So if Wi-Fi control is not a big deal to you at all, don't worry about it. But if that is something you want, then you really need to think about it. It's like, okay, don't buy the cheap one, because if you bought the cheap unit and then you bought this extra, you probably ended up paying more than if you just bought one with it built into it already. Now, also with the Wi-Fi module, everybody's got a different app for theirs. Some of them use a generic app. Some of them use a specific app for their brand itself. And the more well-known name brands will have their own apps that have more functionality. Some of them are really good. Some of the ones like mine are very basic. I like it because it has a setting in there that I can set it to keep it at no lower than 46 degrees in here in the wintertime, which keeps everything from freezing. It keeps paints from getting too cold and things like that. That's great. So that's really handy. Or, you know, it's like, say I want to cool it off in here, warm it up in here. I don't have to come out to the shop to turn it on. I can just tell my phone to do that. So that's a really handy thing to have. It really is. Let's see, my next thing. Oh yeah, and because of that you can use it with Google Home. I don't know about the fruity stuff. I don't do fruit phones, so that's on you. And one of the other things I've got in here, this is a really cool little thing. If say your shop is somewhere else that you're going to, you can actually set up these location-based things if you want to have control over that, to where if you get within, say you're driving to your shop, well, once you get in, so within a certain distance of your shop, hey, it'll kick the air conditioner on, you know, automatically while you're going there. Or if you leave, it will turn it off after you've gone for a certain amount of time. Those things are in some of the apps and can be done with other third-party apps as well. And the neat little thing I've seen in a few, this one doesn't have it, but I guess there are versions that do. And some of these actually have energy monitoring. Well, actually, you have to have monitored how much electricity it's used. Mine does not have that. Would have been kind of neat, but doesn't have that because I went cheap. But it works. All right, mounting. Where do we want to mount this thing? Now, as you can see, I've got mine. It's up on this end wall over here, because this is where I had a place to put the condenser outside. It's up high so it can get the hottest part of the air in the shop, you know, pull the hottest air out because it's up towards the peak. It can blow air down this way. And that's just, there's all these things you have to think about when you place it, where you place it. You don't want to put it where, oh, if I did a whole bunch of grinding and sanding over here, oh no, you do not want that over top of that. No, that is definitely not where you want it. So you need to think about your dust creators, your heat creators, and things like that. Ideally, where I actually wanted to put this unit, and I'm going to turn you around for a second, so you're going to get a little seasick here. Ideally, what I wanted to do was I wanted to put the unit right up here, right up over this door up here. I'm assuming you can see that because my screen is not on, it's on my phone, but I wanted to put the unit up here. And then when I got a secondary unit, ideally, I wanted to do the same thing down here with that door over there. Because if I put that over top of this door, and assuming it fits and all that, and yes, it would be a little tight for certain things, but you know, it is what it is. But right there would be totally out of the way of everything else. You can mount stuff everywhere else. That is basically a useless space up there that could have been used for that. I didn't do that because, again, that thing I was talking about earlier, I was talking about line set length. So you've got that line set length issue to deal with. And I would have had to run across, over, down. I didn't want to do that at the time. So that's where we are with that. And now if you're mounting the ceiling ones, you'll have to figure that out as well. Now, where you want to run your lines, generally most people you will see will run their lines, say from their unit up here, they will take and run straight out the wall and then straight down and then over to their unit. I didn't do that for a number of reasons. One being I have a 2x2 square tube in the way. That's one issue. The other issue is I didn't want that thing sticking out the wall, coming down the wall and looking ugly and horrible on the outside of the building. And that also would have been a hole higher up. And most of our weather comes from this direction here. I don't want a hole higher up that water can possibly ever get into. So it was a cosmetic thing. It was also a rain thing. So my lines actually run inside the wall because I've got, what is it, I have 6-ish inches of wall here, and I ran my line sets down across on top of that square tubing, over here, down and out the wall. My outside unit is basically down below the Greek flag over there. Yes, I do. When I get this wall finished, I need to get a U.S. flag to go up here. Greece is just my favorite place in the world to go. So that is something to keep in mind, how you want to run those lines. So the other issue you do have, if you're going to run those lines on the inside, they're a little noisier. These units do not work the same way as a regular house type unit. The metering device, and I'm going to get technical here, the metering device, the thing that actually takes the liquid and puts a restriction and makes it turn into a gas, is actually inside the unit on the outside. Okay. So what happens is you will actually get more noise on those line sets than you would, say, on a conventional house type line set. You'll actually hear gas moving through them on those, where you would not hear that generally on a house type unit. It's just, it works differently. And that has to do with the way they defrost, because this has a hot gas defrost. I didn't mention that earlier. Sorry. I forgot to write that part down. But this actually has a hot gas defrost. So when it goes in defrost mode, it does not turn this on into air conditioning mode. It just bypasses the refrigerant flow on the outside of the unit. So it puts that hot refrigerant back into the outdoor coils. It's the same thing, way an ice machine works. If you had to, if I'm explaining hot gas defrost, you know how an ice machine works. So, but you do get a little more noise from that. So that's something to keep in mind. You do get that noise. Your condenser mounting can go any one of the different ways. Now, you can mount it on the ground, onto a pad, or you can hang it onto the wall like I have done in mine. Now, I had to add framing in there because it's a metal building. There's nothing there to attach to on a metal building. So I had to actually add framing in mine. I mounted mine in brackets and have it on the wall. You can do either one of those. The second, when you mount them on the wall, you do invite vibration from the unit to make noise into the building. So just keep that in mind. There are also units that are ground mount that are meant for multiple units where you can stack them. So that's another thing that's kind of handy to look at as well. I do not have concrete out here. Had I had concrete over here already, I would have done a standard ground mount type, probably a double stack, so room for a secondary unit on top of it in the future. So I didn't do that. All right, so now the other issue with that mounting of that unit out there is going to be the airflow out of the condenser. Now, let me pause and turn this around. All right, so, well, excuse me the way I film this. I do the Frank Sinatra kind of thing. I go from the beginning to the end, and I really don't like to reshoot things. So bear with me on that. So I was talking about the airflow out of the condenser. Now, you'll see these big fans in these. The way a lot of these work, so if you're mounting this thing outside and you're worried about where this is blowing, generally these fans don't blow straight out like this. It does not come out straight off of here. Most of them, and you can actually put your hand up there, you'll feel them. Most of the air comes from the rim and comes out at an angle this way. It comes out as more of a cone shape around these units. So that's another thing to think about, is when you put this thing on the ground, you actually have air that is blowing down. So if that's an issue or not, it's just a factor in the airflow of these things. So the only thing that may come into is, I do have a tree out here. I got a tree out here, so people are going to say, well, that thing is blowing straight on your tree that's out there. No, it's not. It's going out like this. It's going to cone like this. It's not blowing out the tree. If it did blow out the tree and something happened to the tree and the tree disappeared, sadly, I would not have shade over the shop in the afternoon, but then that would free up the roof of the shop for solar panels in the afternoon to create power all the time. I'd love to put them up there. I don't know if that'll happen or not. So now we're going to get into different kind of units here. There are some units that are sold by Signature Solar under the EG4 brand. And these are basically, they will be a standard looking mini split inside and out, except they'll have 2 more wires hanging out of the other side of it. There are 2 connections over here, and they have a direct solar panel connection. So you can put solar panels on the roof, run the wires down, plug them straight into your mini split unit. And you can set that up to use primarily only power from the solar panels. There's a whole lot of flexibility there. They are really cool units. I really like them. They're really cool units, and there's a lot of flexibility in how you can program that. At the time I wrote this, and I started writing this list of stuff up a year ago. But at the time, the half-ton unit was $1,300. Now I know, we'll back up, and I was talking about, say, hey, it was $500-600-ish a ton. When you're just kind of generally looking at them, there are brands that are more expensive, but I just look in general. I just kind of browse out there, look around. But there's a lot of them in the $500-600 range, and then it starts creeping up from there. So this is a half-ton unit for $1,300. You say, whoa, man, that's a lot of money. Yeah, but the fact that you can put this unit in, throw solar panels up, plug it in, and you don't need any other solar hardware whatsoever. That's it. You don't need an inverter. You don't need batteries. You don't need anything. It just plugs in and it works. And you can offset some or all or most or whatever of your electricity usage of that mini split with those solar panels. And now a 2-ton unit is $1,900. So I don't know what the prices are now. That's just what it was at the time I was looking at them. So, and I skipped something, but also when I was talking about line sets, I left out, there are the different type of connectors. Now these solar panel ones will have what I call them, they're used in the marine industry, but they're a marine fitting that, so you have a fitting on here, you just screw it together, boom, you're done. There is enough refrigerant in the lines to keep the air out. So your refrigerant is actually stored in here. So when they talk about pre-charged lines, well, they are charged, but that's not where your majority of refrigerant is. The pre-charged lines are just there so you can hook it all up, and they will hook up and not get air into them. And if they're a longer set, they will have the extra refrigerant that is needed for a longer line set. So I'm sorry I missed that earlier, but hopefully you watched at this point. But you will have just the standard flare fittings on these here, and the ends of your flare fittings will look, like that. Just a standard flare fitting on a piece of copper, and that's what your fitting will look like. And if you need to cut those lines and you need to make them shorter, which I don't recommend that most of you do that, because you will need something like this. This is a flaring tool. So I've had this one for a few days, but you'll need a decent quality flaring tool that can do a nice smooth flare. There is also some sealant that you can get. There's a sealant you can put on there. I'll put a link in here somewhere for it, but there's a sealant you can put on there that just helps. It doesn't hurt. You just put it on the very surface of the bevel there, and clamp it all together. good to go. Doesn't hurt. It's a compressor oil with some other stuff into it to help seal. So, all right. Now we're going to talk about the biggie. What brand do I buy? Well, if you're looking for ease of installation, I'm going to say, I'm just going to say, hey, go with Mr. Cool or go with the Signature Solar, the EG4s with the solar panels. If you want the solar panel type, you can go with either one of those because they have the easy marine type connections that require no equipment. Because if you don't go that route, you're going to need something like that. You're going to need you're going to need flaring tools, possibly if you want to shorten your lines. You're going to need a vacuum pump. You're going to need a set of gauges. This is from a past life. I don't use these very much anymore, and just going to need that kind of stuff if you're going to do the flare fittings. So the other thing you should do, don't just pull a vacuum on it. Would also be to nitrogen test it first. You fill it with nitrogen. You run it up to pressure. Make sure it holds. Then you pull a vacuum on, you pull the nitrogen out. It helps flush any air out as well as test the system for holding pressure at the same time. So most installers, they don't do that. That's just what it is. But it's something that really should be done. Most people don't. But yeah, it's up to you how you want to do that. So, and I will put down a link below on how to install it because I'm not going to talk about install here. William Prowse does a lot of solar panel and solar battery and inverter videos. His videos are excellent, great information if you want to go solar. Just short to the point, very, very educational. He's very good at just cutting through the crap of everything and say, hey, this is what, this is meet spec, that doesn't meet spec, this works well, that doesn't work well. Excellent channel for all that kind of stuff. And he did a very, very good install video, which I highly recommend that you go watch if you want to install this type of system where you've got a flare fitting. So I won't even get into that. So also with the brands, when I said, the Mr. Cool and the others with those quick, and there are others with the quick connects that you can buy and run with those systems, and they're getting more popular here in the US with those fittings. However, there's a whole bunch of other brands out there. This one here, it's ZOKOP. So I don't know if that is Zokop or Shokop, or I don't know. I don't know how that's supposed to be pronounced. I don't know. I will butcher it either way. There's that. There's Pioneer. There's one that's called Apu, which I believe is made in India. You've got LG, which I think is out of the game now, and I've installed some of theirs in the past, and they were nice units, but they were not any different than a lot of these other units. I didn't see any difference, to be honest. Let's see, and you've got Costway, Senville, and a few others. Pioneer is biggie. I may have said that already. I believe Senville's actually got an office in my part of the world here. Any of those, I'm really not too picky on which brand it is. I will say if you go more towards the Pioneer, Costway, Senville, they seem to have a little more parts availability and a little more support in that behalf. So you might want to kind of, lean that way, do your research. Which brings me into warranties and service. Now, I mentioned Pioneer, Costway, Senville. I know Pioneer has gotten really good feedback from people that have bought them. They seem to be very DIY friendly. So if you're doing this yourself, they seem to be very DIY friendly when it comes to repairs and things like that and sending parts out. I've heard similar from Senville and Costway as well. I don't have any direct experience, so I don't know. That said, I have looked at like the Senville. I've looked at the Senville and Costway units lately as something that I would buy for a 2-ton unit to go in the shop over here to help out with my shop. I do want a 2-ton here. I'd like to expand the shop at one point. That'll need another unit. Would like to have one You know, I have a use in the house. I'd like another unit in there. Uh, some things like that. They're really super handy, great units. You know, and I'm not picky about any one brand. I'm the type of guy that I don't mind putting things in myself. I don't mind fixing myself. So when it comes to the service side, most HVAC companies are not going to want to touch them. They are not going to want to touch these things. And it's like any other industry. They are stuck in I have this inside unit, outside unit, gas furnace, heat pump. You know, heat pumps are a thing. They were, you know, it was like, oh, the world is falling and things. And it took a while for those things to, you know, and I'm talking decades ago, you know, to you guys in the rest of the world and say, oh, the heat pump is this new thing. No, trust me, there's nothing new. There's nothing new. It's just they've gotten better. That's the only thing that's happened with them. They've gotten better, more efficient. But when it comes to repair, you know, the maintenance guys, you know, when it comes to just calling somebody up and, you know, also think about, say, if you're spending $500-600 a ton and say it's out of warranty and you want to call somebody to come out and work on it, and how much is service call going to cost you? I don't know, $100, $150, depending on what part of the country you're in. So you've already sunk that much into it before you've even diagnosed or fixed it. So personally, I see these things as something like, you know, you need to do it on your own. You need to, you know, learn it, do it on your own, figure out a way to do it by yourself. So either that, or you consider it as disposable at that point, where if it's not an easily fixable thing, okay, let's pitch it, get another one, and we'll move on. Now, are some more reliable than others? There is the one brand that I like their stuff, and I don't want to bash them, but they're a big company. They're really popular in the installer side because they get pushed into the networks of the installers. I think they're overpriced, but they do make good units. However, they do have their issues just like everybody else. So, you know, it's just, you know, pick one and go with it. Now, I know this is already an hour long, and I'm sorry, but it is what it is, and I'm almost done. So the last little thing I want to bring up that I forgot to do earlier, and I'll add this into this service area here, is, and I've heard this so many times when I've watched videos of people doing installs that are not familiar with the way these machines work. And that is the service fittings on these things. Now, we'll go over here and look at it. All right, so now these are what you would consider on this unit here are a conventional type service fitting. Okay, you actually have a fitting on both of these to put gauges on. This is not the norm. This is not the norm. This is kind of a holdover from the old days because this is what was available. This is what they used. So your lines come out of here. You take these caps off, and there's a hex screw in here with a seat that closes this valve off. And here is where you put your gauges. You will find on any unit you buy now, it's going to have one fitting on here. That's it. It will only have one. All right. So the reason they only have one fitting, and I will hear this, and I've heard it, like I said, I've heard this many times about this. Well, there's only one fitting. I'm going to have to, you know, cut and solder on another fitting here to put a set of gauges on here to see what's going on when something goes wrong with it. No, you're not. Because these units here, the only thing that you need to do with a set of gauges on these units is there enough refrigerant in it? If you want to do anything to it, recover the refrigerant, load it up with refrigerant again to however many ounces it's supposed to have, and that's it. You are not going to sit there and put a set of gauges on there. You know, you're not going to put these things on here, and there's no hoses. You're not going to put a set of gauges on here and watch these pressures and watch the superheat and all that stuff. You're not going to do that on a mini split. It does its own thing. It's got its own little brain in there that it does what it wants to do. And because the metering device is out here instead of in here, it's a different animal. And generally these things, if you do start getting low on refrigerant, it's going to tell you. A lot of times they will tell you. There will be an error message and things like that on a lot of these in the app. that will tell you, hey, there's something going on here. It's not working right, because it knows it's not they're not totally dumb. They are pretty smart for what they are. All right. Now, this is a power supply that actually came out of this unit, because the story of this unit was this was installed, didn't work. The inside and outside unit would not communicate with each other. Company said, oh, hey, no, not a problem. It's probably, it said, do this, do that. The power supply is bad. So they sent another power supply, swapped it out. No go. Okay. So get a little further into it. They say, well, okay, in that case, we'll just send you a whole brand new outside unit. Okay. They sent that, put it in. Still, no bueno. Doesn't work. I finally get, I keep asking, I say, hey, I think it's a problem with the inside unit. So he says, no, can't be anything wrong with the inside unit. Come to find out, inside unit was miswired at the factory. I had to go back and rewire a few things inside the unit. I don't remember. It's been too long. And once I did that inside the unit itself, hey, it worked just fine. So this is basically brand new. This is a brand new power supply. And I have no use for it because I can't find the inside unit. But if you are ever working on a mini split, this is totally different. This is a big old heat sink because this thing runs on DC. This is not an AC compressor. And that is one thing that can get you into trouble. Now, this one has actually kind of small capacitors. There are some of these that have much larger capacitors than this. These pumps, compressors, it's a pump, that are inside these units generally operate at 380 to 400 volts DC. So if you're working on one of these things, don't just go poking around willy-nilly right after you disconnect it, because that high voltage, and normally I don't care about, your safety is your problem, but this is just, hey, this is something that goes on. This is the way these things are done. This is something you need. The average person is not going to know that these things run at that high of voltage, but that's kind of what it looks like on the inside there. And on top of that, because again, these things are not just click on, click off. This is part of the rest of the harness where these are all temperature sensors for different parts of the unit. Like I said, it's a little smarter than the average duck. So this is your outside temperature right here. See it'll be sitting right here on the other side. This has a lot to do with your defrost temperature, and so do these as well, to make sure things don't freeze up and so on and so forth. So that's about all I've got, and I have an hour worth right here. I don't know if anybody's going to watch it to this point, but if you did, I hope you learned something. I hope you gained something useful from it. I'm just full of useless information sometimes, and I research the crap out of everything. And I'm the type of person that when somebody works on something or wants to know about something, I say, oh, go ask Robert. I'm that guy. So if I don't know, I will. I will dig and research and learn whatever it is about something that I need to. So, hope you found it useful. Hope you found it handy. And hopefully in the future, I will get some more mini splits out here in the shop. I'll get some more insulation and make this just a nicer place to work. And maybe one or two for the house as well, because there's some things in the house I'd like to do as well. I like it cold at night to sleep. So colder than what the air conditioner wants to do. So, I'll just keep rambling on here for another hour until I hit the 60-minute mark. There's 60 minutes right there. So thanks for watching. See you later.